Okay, today we are talking about applications of functions, and we will do this worksheet in just a moment. But several of you have had questions over yesterday's, and I'm going to go ahead and get some of those questions answered. Let's do number 16 together. Will someone please read me the two equations for 16? Square root of 2x plus 5 and negative 2x plus 7. Is that correct? Okay, so if we're solving this system algebraically, I know that y equals this, and I know that y equals this, so I also know that this equals this, right? So I have the square root of 2x plus 5 equals negative 2x plus 7. All right? Now, how do I get rid of the square root? I square both sides, right? If I square that side and I square that side, that's what it looks like, right? What do I get? What am I left with on the left-hand side? 2x plus 5. Anytime I'm squaring something that I'm also taking the square root of, I just get whatever's inside. Okay? Equals what? Isn't it really this? Right? Which means I have to distribute here and get, whoops, that's a negative 2x, isn't it? And get 4x squared. And do that and get negative 14x. God bless you. And do that and get negative 14x. And do that and get 49. Does that make sense? Okay. And that still equals 2x plus 5. Let's go ahead and combine terms on the right hand side. So I have 2x plus 5 equals 4x squared minus 28x plus 49. Okay, so far? Am I going too fast? Okay. What kind of problem is this? It's a quadratic, which means I need to set it equal to 0. So then I need to subtract 2x on both sides. And I need to subtract 5 on both sides, correct? So I have 0 equals 4x squared minus 30x plus 44x. Yes? Okay, so I have two choices here. I know in the video yesterday I said that you really want you to do one thing. Well, Emilio and I had a conversation this morning, and he realized, and some of the other people in here and in other classes realized, that if we get to here and we can factor it, shouldn't we do that? Isn't that easier? For the most part it is, isn't it? Okay, so would you rather factor this, or would you rather use the quadratic formula? You want to factor it? Okay. If I'm going to factor this, first thing I want to do is I want to take out a 2 from each term because they're all divisible by a 2. I'd love to take a 4 out of each term to make this leading coefficient a 1, but I can't because 30 is not divisible by 4, is it? Okay. So if I divide a 2, like I divide both sides by 2 like that, I end up with 0 equals 2x squared minus 15x plus 22. Okay? So, if I've decided I want to try to factor, does factoring always work? No. So I really have to, decide, make a good choice. But you have decided we want to try to factor this one, so I'm going to think out loud for you. Okay? All right. When I'm factoring, I need AC and I need B, don't I? What is AC in this particular problem? 44, and B is negative 15. So the numbers that multiply together to be 44 are 2 and 22, or sorry, 1 and 44, right? But we know that's not right. 2 and 22, 3 doesn't work, 4 and 11, ooh, won't negative 4 and negative 11 give me a negative 15? Okay, so I need to rewrite this problem to be 2x squared minus 4x minus 11x plus 22, because I'm factoring by splitting the middle term into two parts. Okay? Now I factor by grouping. I just look at the first two terms. Factor out what they have in common. What do they have left? X minus 2, right? Okay. Now just look at the second two terms. What do they have in common? we're going to take out a negative 11, aren't we? What do they have left? X minus 2. Okay? So we have 2x minus 11 and x minus 2. Now keep in mind, I've kind of dropped it off, I've been lazy about it, but keep in mind that both of these two actually still equal 0, right? That helps us be able to know what to do our next step. We have to set each one of the factors equal to 0, don't we? So I can add 11 on both sides, and I get 2x equals 11, and I can divide both sides by 2 and get x equals 5.5. Or I can add 2 on both sides and get x equals 2. Now, when we did this before, that was it, right? All we were doing was figuring out what x equaled. But because of the situation that we're in, these are our original problems, right? What do we have left to solve for? Y. We have to find y. So our final answers down here at the bottom of the page are going to look something like 5.5 something and 2 something, right? This is an x value, that's an x value, right? I can't put them like 5.52 into one point, can I? Because these are both x values. So I have to go back up here to the top. Which one would you choose? The top one or the second one? See, I would choose the second one as well, okay? The second one is y equals negative 2x plus 7, and I need to put in 5.5, and then I need to put in 2, right? What is negative 2 times 5.5 plus 7? Well, negative 2 times 5.5 is negative 11, isn't it? What's negative 11 plus 7? Negative 4. And I put it in with this one because I use the 5.5 as my x value, so this, what we get out, is our y value. Then we have to do it again. Y equals negative 2 times 2 plus 7. So negative 4 plus 7 is 3. And those are my two answers for that problem. I personally think it's ridiculous how much space they give you to work on this page, because you need way more than that. I used a whole page. Of course, I write big and I like to leave spaces, but that's just me. You're okay with it? Sierra is definitely okay with it. Okay. Okay, so you also wanted to see 19, is that correct? Okay, what are the two equations on 19? I'm sorry, I didn't hear the rest of it. 6 over x plus 4, thank you, and? So it's not y equals? So it's negative 3x plus 4y equals 18. Oh, so we had to do it like there's a whole nother step on this problem, yes? We actually had to solve for this y. So we need to add 3x to both sides. Wait, do we? Do you have to, though? I mean, I will if you want me to, but I need to make sure you understand that you don't have to do that. If I know what y is, couldn't I just plug that in right there? What y is? Okay, we'll worry about that later. Let's do it the way you want to. That's fine with me. So 18 plus 3x. If I divide everything by 4, it's y equals 18 plus 3x over 4. Okay? So if y equals this and y equals this, can't I set these two things equal to each other? 6 over x plus 4 equals 18 plus 3x over 4. How do I solve this kind of problem? How do you want to solve it? Cross multiply would be good. So there is 24. Here is x plus 4 times 18 plus 3x. Okay? Now we have to distribute. Very good. That gives me 18x. That gives me 3x squared. That gives me 18 times 4. What is 18 times 4? 72. And then plus 12x, right? So that equals 24, doesn't it? I need to combine my like terms. I've got an x term here and an x term here. So that gives me 24 equals, and I want to kind of get it in the right order at the same time, don't I? Okay, so I have 3x squared. 18x and 12x is 30x, good. And then plus 72. So now when I subtract 24 from both sides, I get 0 equals 3x squared plus 30x plus 48, right? Okay. So now we're at the point. What do? We only have one variable. All we're trying to do is solve for x. What kind of a problem is it? It's a quadratic. So we can either factor or use the formula. What do you want to do? Let's try to factor it. Even if I'm using the formula, what would I want to do first? Are all three of these divisible by 3? So even if we're going to use the quadratic formula, isn't it easier to have smaller numbers? Okay, so 3 divided by 0 is still just 0. That's x squared. That's 10x. And that is 16? 16? So does anybody happen to know two numbers that multiply to be 16 that add to be 10? How about 8 and 2, right? So x plus 8 and x plus 2, and that equals 0. Since I have two factors that multiply together to give me 0, I need to set each factor equal to 0. So x equals negative 8, and x equals 2. So once again, I'm going to have two answers, and one of them is going to look like that. Tell me. Thank you very much, negative 2. And one of them is going to look like that, isn't it? So we go back up to the beginning. Which one do you want to use this time? Top one? It doesn't matter since they're both like fractional, aren't they? Okay, so y equals 6 over x plus 4. If we're putting in a negative 8, we have 6 over negative 8 plus 4. Negative 8 plus 4 is negative 4. So I have 6 over negative 4, and that simplifies to? Very good, negative 3 over 2. Okay, if I put in negative 2, I get 6 over negative 2 plus 4. Negative 2 plus 4 is 2, so I have 6 over 2, and that's 3. And those are my two solutions. Okay? Are you feeling better about those? Good. Good, good. Okay, so to today's applications of functions. Okay, for time's sake, we're going to start on the back. Partially for time's sake and partially because this is one of my favorite problems ever. A parachutist calls from her cell phone. Hey, Walter, you'll never guess where I am. I'm parachuting down over your neighborhood. Even though I'm descending at a constant rate of 4.8 feet per second, I'm afraid my landing will be a little rough. So do me a favor, go outside and get on top of your roof, and when you see me pass overhead, throw me a pillow. What? So when Walter saw her, the parachutist was 40.6 feet above the ground. Walter threw her the pillow, and she missed. But she caught it when it was on its way down. Okay. You see why it's my favorite problem? Can't you just imagine this problem? Isn't this so real? No, not at all, right? But it's funny because they try to make it look like it's real. Okay, we need to look at the picture. We definitely need to look at the picture. Okay? First of all, if this is as tall as the guy is, look how tall he is compared to his house. Oh my gosh. And have you ever been parachuting? Have you ever seen people go parachuting? After their parachutes comes out, are their legs still behind them? No. So, okay, we're working with a very realistic problem here today, okay? As silly as the problem seems, there is some good math, so let's use it for its value. Okay, we can laugh and have fun with a parachutist who's calling somebody on her cell phone when she's parachuting, and she's calling a man who's as tall as his house. Okay, so what linear function can be used to find the parachutist's height in terms of x, since which is the number of seconds since Walter threw the pillow? Yeah, he probably does have a really good arm. Okay, and that's okay. He is as big as the house, so yes, that does help. Okay, so we are trying to find a linear function. What kind of thing do we have? What kind of equation do we have to plug in a linear function? Anybody? What about like mx plus b? Have you ever heard of that before? Oh my gosh, you guys are killing me. Slope intercept, remember that? Slope intercept? Okay. So, what do we know? Do we know how fast she's going? 4.8 feet per second, so what would that be? That would be our slope, wouldn't it? Okay. So y equals 4.8x. And then what else do we know? Where'd she start? Where did he see her first? 40.6. Okay. Now, lest we get going too much further and realize we have this equation wrong right now, we need to make sure to think just a little bit about this. Okay. She is going 4.8 feet per second, but she is also descending 4.8 feet per second. So what should that multiplier actually be? Negative. Okay, make sure you keep that in mind, all right? So we are also given a function of the pillow. We don't have to find that. Yes, sir. We're not worried about that right now. We're worried about how fast she was going and when he saw her first. That this equation is for the parachutist. Okay, this equation is for the pillow. We're not really worried about him yet. Okay, give us a chance. Okay, and if you think about it, that's already taken into account, isn't it? In that equation, the 15 feet. Okay, so treat these two functions as a system and solve it. What? Oh, if they both equal y, can't I make them equal to each other? Okay, wait, but this one equals h. It doesn't equal y. Oh, so it really does? Okay, so we're going to say negative 16x squared plus 40x plus 15 equals negative 4.8x plus 40.6. Okay? What do you want to do first? We're going to equal them to 0, right? We got to get it equal to 0. So we add 4.8x to both sides. And we need to subtract 40.6 from both sides. Right? So we have negative 16x squared plus 44.8x minus 25.6. You guys really want to try to factor that? Yeah, I don't either. Okay, so do we have another choice? Quadratic formula. And I can tell by how you said that you are so excited about using quadratic formula. So let me ask my question again. Do we have another choice? Don't we have this choice? Don't we have the graphing choice? So if I go home and make a new document without saving the old one and add a graph, can't I put these two equations into my y equals and find where they intersect? Do we always have... I know this class is called algebra. I get it. Okay? But sometimes isn't graphing a better choice? Okay? So, because, we already started this and we're already here. I don't want to do that. I mean, I could, don't get me wrong. You could. I won't get you wrong. But if we're trying to think smarter, you know what I'm saying? Plus 40x plus 15. So there's my first equation. And then I need to get my second equation in, which is negative 4.8x plus 40.6. Okay, so clearly mine is broken. Oh, I'm wrong. So menu, window, settings. I can tell, I mean, my line even doesn't cross till 10, so I can go from 0 to 10, right? Still, it's just my y values that I have to figure out, isn't it? 0 to 45. Where did you come up with 45? Okay. So we know that the line intersects, or the x-axis at 40.6. That's some good thinking, Erin. Okay. That's not always going to give us the answer, but it's good thinking, isn't it? Okay. So let's go find my intersection. Menu, analyze the graph. Find the intersection. Let's find this one over here first. And that point is 0.8 and 36.8. So let's go find the other intersection. Let's analyze the graph to find the intersection. And my left bound is here and my right bound is here. And that point is 231. So what does that mean? I understand that those are my intersection. I got that, but what do they mean? So this one's the first one, right? 0.8 and then 36.8. So she missed the pillow at time of 0.8 and height of 36.8. Very good. When did she catch the pillow? At 2 seconds and 31 feet. Okay? How much time transpired between when the parachutist missed the pillow and when she caught the pillow? When did she catch it? At 2 seconds. When did she miss it? 0.8. 1.2 seconds. How much time did the parachutist have to adjust the pillow between when she caught it and when she touched the ground? Dun dun dun. When is it crossing? When is she hitting the ground? How can we figure that out? Menu, analyze. What is that place down there called? It's called a 0. Which graph am I talking about? I'm talking about that one. My lower bound is here. My upper bound is here. Can you see it? I can't see it very well. 8.46. So how do I figure out how much time passed between when she landed and when she caught it? Yeah, 8.46 minus 2, isn't it? How much time did she have? 6.46 seconds. Good job, guys. Good job. You have all this? What did we not write that we should have written on problem number 2? It does say, what do the intersection points mean in the context of the problem? So at 0.8 seconds, she missed the pillow at 36.8 feet. At 2 seconds, she caught the pillow at 31 feet. Okay? Any questions, guys? Okay, so you have the front to do. You have problems 1, 2, and 3 to do for tonight. I plan on working until the bell rings. Is that okay with you? Okay. When taking students on an extracurricular road trips, the school typically pays $450 to rent a bus using Regal Charter Services. However, the school secretary decides to call a competitor, see if the rates are better. Here's what the representative from Fly-By-Night Rentals has to say. Regal charges a flat fee, but think about the cost per student. With Regal, if only 4 students go on the trip, that's $450 divided by 4, which is $112.50 per student. In this case, Fly-By-Night would only charge $78 per student. Think of the savings! But what about large groups? With 54 students, you'd still be paying $450 divided by 54, which would be $8.33 per student. With Regal. With us, 54 students is only $3 per student. Can you believe it? It's all because we use a linear model to determine the price per student. It just makes sense. Of course, you have to take between 4 and 54 students on the trip, but that's no big deal. So can we count on your business? Help me fill in this table. How did the lady get Regal's prices? So how are we going to get this next term right here? 450 divided by 15, 30. So what if we're taking 30 students? Oh, 15. Imagine that. What about 45? Oh, geez, that's 10. Okay, how did we get that? What is the function rule? 450 divided by x. Is that a function rule? I'd prefer it be y equals, but that's okay. Finish this for homework tomorrow, and I hope you have a great day.